Hey, welcome to this first part of our series on section 7.3 in algebra, the special products of polynomials. This time we're going to do the exploration a little bit differently because there's a couple of pretty distinct skills that we need to talk about. And this first one that we're going to do is going to be the sum and difference pattern. And then we're going to do the square of a sum and the square of a difference pattern. Those two patterns we're going to do together. So right now we're going to go through everything in section 7.3 that has to do with the sum and difference pattern. First up is this algebra tile exploration. Looking at letter A, this is called a sum and difference because, as you can see, the first term of each of those binomials is x. The second term of each of that binomial is going to be 2. And we have an addition in the first one and a subtraction in the second one. Now, they've nicely modeled the algebra tiles here. And you can see this is x minus 2 and x plus 2 over here. And multiplying all the algebra tiles, everything looks pretty good. This first row, x times x is x squared. X times -1 is -1. X times -1 is another -1. Right on down the line. All of these look really good. Get used to seeing this pattern because, this is the way that things get done. But something interesting happens here with this sum and difference pattern. And what happens is when we start looking for zero pairs, which is what I would do next, none of those long bars actually make it past. They all cancel out through zero pairs. And so the result, is this is an x squared, and then this is -4. So the result is x squared minus 4, which is interesting to us because if you take a look at what we have here, we've got x squared minus 2 squared. Notice how we just take each of the parts, square them, and then subtract them. So the sum and difference pattern works out really what we would say is regular. Now, the sum and difference pattern is actually one of my favorite patterns in algebra. I like to use it a lot. I really enjoy when I recognize it, and hopefully you will too. Let's take a look at letter B. Maybe we'll see it again. Look at this, 2x and 2x, and then -1 and +1. So it doesn't really matter if you have -1 and +1. Let's use what we learned already over here. And we know it's going to be the first one squared minus the second one squared, because it is that sum and difference pattern. So we're looking at 4x squared minus 1. Let's see if it works out with the algebra tiles. We have this x tile canceling out with that x tile. We've got that positive x and this positive x canceled out. Let's count here. We've got 1, 2, 3. That's 4x squared tiles. And we've got one -1 tile. And when you put that together, that's 4x squared minus 1. So again, this sum and difference pattern, one of my favorites. Love to use it. Let's move on and see this at play somewhere else. Okay, here's more. Let's do letter A. That's the sum and a difference. You've got x, you've got +3, and you've got -3. Over here in the algebra tiles, we'll go ahead and do the multiplication. X times x, that's x squared. X times 1 is x. X times 1, x again. And x times 1 is x again. Moving on to the second row, we've got a -1 multiplied by an x. That's -x. -1 times +1, it's -1. And then -1 times +1, and -1 times +1. Now this third row is pretty much the same thing as the second row. And of course that fourth row is exactly the same again. So now we're ready to see what we got. This algebra tile and this algebra tile, those cancel out. We got one same shape, one positive, one negative. We got this tile and this tile canceling out. And then finally we've got this x and this negative x canceling out. So the only tiles that are left here is an x squared tile and 9 tiles. I mean 9 -1 tiles, which is -9. And then 6 plus -9, sorry, x squared plus -9 is just x squared minus 9. Now, with the algebra tiles, that kind of takes a long time, so it's better off if we have our pattern instead. So let's take a look at number 3, or letter C, and we'll use our pattern this time. The sum and difference pattern looks like this: a plus b multiplied by a minus b. Ooh, I'm noticing this is kind of creeping off of the window. A plus b multiplied by a minus b, that's going to be a squared minus b squared. You're just going to substitute the numbers. So I notice that a, in place of the a, I have a 3x. So I'm going to take all of the a's and I'm going to make them 3x. Now the next thing I see is that in the place of the b, I have a positive 1. So you guessed it, I'm going to replace all the b's with 1. And that's really my answer. I probably want to simplify that. Why don't we simplify that? The quantity of 3x squared is 9x squared, and then 1 squared is just 1. So look at that. Pretty good. So that takes care of our sum and difference, our notes on that. Here you can see the pattern, sum and difference. I kind of like the way I did it myself a little bit better. So why don't we look at some of these practice problems from homework. Okay, here's one. T minus 11 and t plus 11. So think about this. Which pattern are we going to use? Obviously, it's going to be the sum and difference formula. Let's figure out which of those variables is going to be a and which one's going to be b. Well, it looks like t is in the same position as a. So let's change all of the a's into t. Let's copy it, start replacing. And then now, what number is in the b part? And it is 11. So change all of the b's into 11. Now all we have to do is simplify. Okay, well, t squared, that's just t squared. And then 11 squared, well, that's just 121. So it looks like my answer is t squared minus 121. And it is. That's the correct answer for question 12. See how easy that was? Kind of fun, too. Let's take a look at 15. 15 is probably going to give some people nightmares. We got 1/2 c plus 1/3 and 1/2 c minus 1/3. It's a sum and difference formula, so there's really nothing to it. Get our formula. Let's figure out what we're going to use for a, and it looks like a is 1/3 c. So let's change all the a's into 1/3 c, okay? I mean 1/2 c. And then what do we have in the b position? And in the b position is 1/3. So we're going to change all the b's into 1/3. And then now we just have to take the time to simplify. Don't worry, I'll help you here. 1/2 c quantity squared, that's 1/2 times 1/2, or 1/4, and then c times c, which is c squared. So we get 1/4 c squared. And then 1/3 times 1/3, that's just 1/9. So there's our answer, 1/4 c squared minus 1/2. Nice. So that was actually a really difficult problem for a lot of people, but not for you. Let's look at number 20, because this doesn't seem like it would be a sum and difference pattern, but it really is. So I look at that, 49 and 51. Now obviously they're different, but they're both really close to 50. In fact, I have got one number that's greater than 50 and another number that's less than 50. 49 is actually 50 minus 1, and 51 is 50 plus 1. And does that look like a difference of squares? Yeah, it kind of does. It looks like that sum and difference pattern. Let's compare. Yep, it looks like the A is 50, and it looks like the B is 1. So in order to do this quickly, quote unquote, we can just substitute all of the A's with 50, and then substitute all the B's with 1. Now that might not seem like it's an easier thing to compute, but it kind of is. I mean, if you are paying attention with the multiplication and how that works, 50 times 50 is just 5 times 5. It's 25. Multiplied by 10 times 10. Well, 10 times 10 is 100. So 2,500. 1 times 1 is still 1. So that gives me 2,499. And that's a pretty good way to mentally multiply those two numbers. Now, it's not always going to work out that nicely, but in this case it does. So that's all of the problems that we wanted to go over with this one. There's another video that's coming that's going to be on the other two special patterns, squaring a sum and squaring a difference, and that'll definitely be linked to this video. We'll see you next time.